Good afternoon. I'm happy to open our session on nature-based solutions application in semi-arid climates. Nature-based solutions are defined by the IUCN as actions to protect, sustainably manage, and restore natural or modified ecosystems that address social challenges such as climate change effectively and adaptively, simultaneously providing human well-being and biodiversity benefits. Nature-based solutions are at the heart of our sustainable answer to global change. As we try to tackle these three global crises, the biodiversity crisis, climate change, and pollution, all man-made crises, we need human-made solutions which go hand in hand with nature recovery and based on nature. Over the years, we have moved from the framing of conserving nature for itself to conserving nature despite people, to conserving nature for people, and we now understand that people and nature are one, and we need to take a multidisciplinary approach which includes social, economical, ecological, and medical considerations to enable sustainable life on Earth, and nature-based solutions are at the heart of this approach. Nature is the basis, the foundation of our economy and of society. The only sustainable solutions are the ones that are beneficial for the economy, the people, and to nature. So we can't have conservation or development. We have to rethink development and how we can use nature sustainably as an economic strategy, rather than something that gets in the way of our developmental needs. In our session, we will focus on arid environments. Utilizing nature-based solutions raises unique challenges in densely populated countries like Israel, and even more so in semi-arid conditions. Such challenges include restoration and protection of wetlands and streams, and cultivating resilient and biodiversity-sensitive forests where water is scarce, or promoting solar energy, agriculture, and urban nature reserves where land is scarce. In this side event, we will share Israel's experience in the application of nature-based solutions under such conditions. Our first speaker will be Dr. Doron Merkel, Chief Scientist of KKL-JNF Israel, and his talk is entitled From the British Wetlands to Agamon Hula Wetlands, the global lesson from the drainage and reflooding of the Hula Marsh in northern Israel. Doron, please.
Thank you, Noga. I will try to share my presentation now. Noga, can you see my presentation?
Yeah, we do.
Great. So in this presentation, I will describe the history of wetlands in the Hula Valley, northern Israel, stressing the lesson that we should learn about preservation our wetlands. But first, let's speak about wetlands in general. A wetland is a shallow water body, usually with dense aquatic vegetation. Wetlands store carbon mainly in peat soils. Peat is a soil rich of organic matter due to the slow decomposing of the plants in wetlands. Wetlands also slow and clean flow of water downstream and support the abundance of plant life and wildlife. Here you can see the different types of wetlands and some famous examples from the world. For example, South Everglades in Florida are salt marsh, the North Everglades and the Pantanal in Brazil are swamps, and in Great Britain, Most of the wetlands are fens and bogs. Some of them are swamp and freshwater marsh. The historic Hula marsh, which we will speak today about, is defined as freshwater marsh. But let's speak a little bit about the British wetlands. The rain-drenched lands of Great Britain offer perfect conditions for the formation of wetlands. Actually, and naturally, the area of Great Britain was mainly wetlands. However, the UK wetlands are threatened. More and more wetlands are drained and dried for housing and for agricultural development. Some traditional management of wetlands has been replaced by industrial scale use, and also raised bogs and low fens and peatlands have been destroyed by pit cutting for fuel and use in gardens, like you see in the picture to the right, to the down right. And now let's go back to the Hula Valley and first ask ourselves, how did the Hula Valley was formed? And for that, we should go to the geological history of Israel and see that about 5 million years ago, the Dead Sea Rift Valley was formed. And within the Great Rift Valley, few water bodies were formed. The first one was the Dead Sea, about 5 million years ago. The second was the Hula Lake and Marsh, about 1 million years ago, located between the Golan Heights to the east and the Galilee to the west. Finally, the Sea of Galilee, which we call in Israel Lake Kinneret, is the youngest, only 20,000 years old. So now you know that the Hula Lake and Marsh are about 1 million years old, and they also served the habitat for unique fauna and flora, mainly papyrus, cattle, and reed. You can see on the map to the right, the map of the lake, the ancient historic lake, with an area of about 13 square kilometers, and the swamps and marshes with an area of about 45 square kilometers. Also, you can see an original photo of a local Bedouin floating on a papyrus mat back in 1905, and to the left, a water buffalo. We spoke about the drainage of the Hula Valley. It was decided to drain the Hula Lake and Marsh, and in 1951, the Hula Lake and Marsh were both drained totally in order to use the dry land for agriculture, not only, but also to defeat the malaria and to decrease water loss due to evaporation. Now you can see that the marsh and the lake disappeared, and today we look at it as an ecological environmental mistake. But the question is, could it be predicted then, 70 years ago? So now let's see a short video about the drainage of the Hula Lake and marshes.
In 1951, Karen Kayemet Lazriel, the Jewish National Fund, began planning and executing the grand and complex engineering project. Huge excavators placed on rafts deep in the Jordan Channel. They created 2 large drainage canals, one of which became the route of the New Jordan River. The plug was then opened, and the water in the lake and Hula marshes began flowing to the Kinneret. The water was drained within a few months. Some of the Jordan channels were dried, and a dam redirected most of the Jordan River water to the Eastern Canal. This resulted in the exposure of tens of thousands of acres of fertile peat used by the northern farmers in order to transform the valley into Israel's largest food producer. Reduced evaporation of the dried lake and marshes led to an increase of millions of cubic meters flowing to the Kinneret.
Okay, and in regard to the consequences of the drainage of the Hula, 20 years later, in the 1950s, after the drainage, the peat started to suffer from few negative processes. First, spontaneous peat combustion due to the oxidation of the organic matter. Second, loss of the fertilizers, of fertile soils and drop in agricultural benefit. And third, nutrient leakage to the Sea of Galilee, Lake Kinneret downstream, harming its water quality due to enhancing the eutrophication of the lake. Therefore, it was decided in the 1990s to reflood a small part of the valley back again. In 1994, the KKL-JNF led the construction of a reflooded small-sized wetland. We call it Hula wetland. The wetland first rehabilitated the peat soil by stabilizing the groundwater level. Second, it prevented nutrient discharge to the downstream Sea of Galilee. And third, turned to be an ecotourism park. Now you can see here the water running to the small wetland, and that's how Hula wetland looked like 1 month after the reflooding, and that's how it looked like 3 years after the reflooding. KKL-JNF and the Israeli Water Authority were wise enough to initiate research and monitoring program from the very beginning of the project. As you'll see in a minute, it finally led to a better nature-based management of Hula. Me personally, I was lucky enough to conduct my PhD study in the valley. In the picture to the left, that's me studying the biogeochemical cycles of sulfur and iron in the Agmon wetland 25 years ago. And in 1996, we faced a new problem, a dramatic decline of the aquatic vegetation. During the summer of 1996, a decline of the aquatic vegetation, mainly Tifa domingensis, cattle, in Hula was revealed through the monitoring and acquired by the research of the sulfur and iron redox system. It was then mitigated by managing a shallow water level that allows oxygen to oxidize the reduced iron and control the redox. Yes, it was part of my personal study regarding the biogeochemical cycles of the Agmon wetland. It took a few years until 1999, and our recommendation was accepted, and Agmon wetland was functioned since then in reduced shallow water level. The aquatic vegetation was reclaimed. However, the surprise came from the wildlife biodiversity, especially birds. The shallow water level led to increase in number of cranes which winter in Hula wetland instead of continuing to Ethiopia. Moreover, pelicans, herons, egrets, ibises, cormorants, moorhens, and mallards were adapted in the wetland. Hula wetland, after 20 years, became an ecotourism attraction. It turned to be one of the best birdwatching sites in the world. And in November 2019, KKL-JNF opened the Stephen Harper Hula Visitor Center in the Hula. Let's see a short video about the reflooding and the consequences.
The comprehensive solution enabled the development of life in the valley. Concurrently, agriculture began to thrive in the valley along with the field crops including peanuts, sweet potatoes, corn, peas, chickpeas, wheat, and more. Flora and fauna returned to the valley, and species considered extinct reappeared. Millions of migratory birds came back to rest in the valley during their journey. The Crane Project is a unique example for the joint existence of nature, birdwatching, and agriculture in the valley. The Hula Valley is developing, serving as a model of sustainability, a positive and long-term perception by which humankind enjoys nature while contributing to it, protecting it, and maintaining it. Agamon Hula, the Hula Lake, in the heart of the valley, is among the most important nature and birdwatching centers in the world.
So Agamon Hula wetland became a multi-purpose environment. It supports different ecological services. First, it's stabilizing the groundwater level, improving agricultural yield. Second, it prevents nutrient leakage to the downstream Sea of Galilee. And last but not least, it became a leader ecotourism and bird watching park. And now I will summarize. Have we learned a lesson? We've seen that wetlands contribute to the environment by storing carbon, cleaning water runoff, and supporting fauna and flora. We've seen also that we should preserve the wetlands from drainage, drowning, and peat mining. Reflooding or rehabilitation of wetlands should be followed, as we've seen, by monitoring and even by research for nature-based management. And finally, a multi-purpose wetland which supports few ecological services is more sustainable, ensuring its long-term life. Thank you very much.
Thank you very much, Doron, and I apologize for all the difficulties. We don't have time for questions right now, but if any of the viewers would like to ask questions at the end, if we have time left, please raise your hand and we will take answers for all the talks at the end. The next speaker is Dr. Gilad Ostrovsky. Gilad is the Chief Forester and Director of the Forestry Department at KKL-JNF Israel. And Gilad will talk about natural regeneration as basic approach to combat wildfires and increase resilience and biodiversity of the forest. Gilad, please.
Hello, everybody. I will share my screen. Noga, can you hear me now?
We hear you and we see the screen, but can you please move to presentation mode? A full screen mode?
Yeah. Okay.
Okay, now.
Okay, so my name is Gilad Ostrovsky. I'm the Chief Forester, and my talk will be about natural regeneration as a basic approach to combat wildfires and increase resilience and biodiversity of the forest. So let's start. I would like to start from the bigger picture, from our policy and guidelines that focus us on goal-oriented, sustainable management of forests and open spaces. And the basic concepts that we like to emphasize are natural processes and increasing diversity. Intervention should be smart, and we try that our impacts will be small as possible. And we also like, when we manage our forests, to put emphasis on enhancing local heritage that we find a lot in the forest. So moving on from the big principles, one of our basic concepts forests are very basic to our activities, and our strategic approach, which I want to think is quite unique, based on analyzing the forests according to land use designations. As you can see here in the drawing, it's Hakdoshim forest next to Jerusalem, part of its master plan that was made about 8 years ago. And as I said, it's very basic to our strategic approach to analyze and to fix those land use designations. So I'll start from in the left side, from bottom to up. First of all, we can see the fuel break. Fuel breaks, we have two of them, two types. One of them is along and attached to cities and villages to protect them from wildfires. And the other, which is well seen in the drawing, the long red lines, are fuel breaks in the forest, which allow firefighters and fire trucks to get in, to have access during the fire, to fight the fire and hopefully to shut it off. And so this is one land use designation. The other one, recreation. I would say that the forest in Israel, but I believe elsewhere, is a key player in terms of recreation to the general public. We can see those areas that are designated here. Recreation generally requires us to a very close intention, and very usually they are intensive managed because we have a very specific targets. The next one in green is natural assets. For example, a very impressive cliff. Another example should be endemic species of flowers, other plants, animals, and so on. We want to find them, to know about them, and to manage the specific areas to support them and to have access to them. The fourth is cultural and heritage. We have a lot of them in the forest. It could be an archaeological ancient site. It could be ancient agriculture that we can find very nice terraces all over the Judean hills, for example. And our management efforts will be to keep them, to manage them in accordance to save this very unique heritage. The fifth, which is very specified here in blue, it's for research. LTER stands for long-term environmental research, and we have certain plots that we manage and we actually conducting researches within the forest, and we have a lot of information that help us to manage the forest. And the last one, multiple use, as you can see, is the majority of the area in Hakdoshim forest, and I believe all over Israel. It's what we call the big forest for itself, with its own values. And it gives us the whole bunch of ecological services that the forests give us. And what is very important to mention is those designations actually help us to choose and to prefer activities and management in the forest, which is very, very important. So this is, in brief, a very basic concept of our strategic approach. And then the wildfires become more frequent. A few pictures, unfortunately, in 2021, over 15,000 acres were burned down in Israel. As we can see by the data, fires become more frequent, large areas being burnt, and we believe it has to do a lot with climate change, and we should be ready when we have to think what we are going to do. A very recent example is from Jerusalem Mountains last August. As you can see in the picture, more than 3,000 acres burned down in Hakdoshim and Hasata forests, very near to Jerusalem, next to the main road to Jerusalem. In the areas there are more than 6 villages and small towns. The consequences were very harsh. As we can see in the picture, the intensity of the fire was high and very high, and large portions of the forest totally burned down. And this is only one example of few very big wildfires. In Israeli terms, it's very big, and we have to think what we can do now with it. So first step when we think about wildfires is go back to the planning table. Planning is very, very important. And we go back to our master plans and management plans, and what you see is a map that describes distribution of desired vegetation formations. This map represents the patchy character of the forest that we would like to see. It's not the current situation of the forest, but we manage the forest according to this planned vegetation formation distribution. For example, you can see the green shaded, which represent mostly mixed forests and coniferous and mixed coniferous, but beside them we have also oak woodland, shrubland, fuel breaks, eucalypt, orchards, and we get a big picture of very patchy forest which support heterogeneity and diversity. And this actually pre-planning that we made help us to choose the actions that we can do now when we want to prevent fires or to manage the forest after a big fire. So just to remind us, when we talk about natural regeneration in the forest, it has many faces. Some of them are beautiful. So we have, the germination of pine trees, which is very strong after fires, and we receive this sceneries that we see in the right down picture. But other types of regeneration could be from leaves, could be from the trunk itself, from the roots. And what we do with this is actually conducting very careful surveys to assess natural regeneration. And here I have to emphasize and to recall, natural regeneration does not mean hands-off. It means smart intervention. If we want to support natural regeneration and to build our forest upon this principle, it comes with smart interventions that we have to decide and act. And let's bring a few examples. First of all, when we talk about fires, fuel breaks. And what we can see here in the picture is a fuel break in the forest itself along a dirt road, which allow firefighters and fire trucks to get in. And we can see the very low cover that we want to achieve. You can see in the front of the picture a small seedling of oak tree. Generally, we prefer broadleaves over pines. So we have this goal-oriented management, and then that means in terms of fuel breaks, a very intensive management, thinning, pruning, grazing, and some more actions to make sure that our fuel break will be efficient enough in the next fire to come. When we talk about management, we have spatial protection from grazing. In those three pictures, you can see the red arrows indicating the spatial protection that we fix around small seedlings that we find in the forest with different coverage types that you can see in front of you. We fix them especially to protect from grazing. In Israel, we have a lot of grazing, mainly from cows, sheep, and goats. And this construction will be with us for 5 to 10 years to protect the seedlings until the tree will be high enough, and if it grows well, we can put it off those protection and we help the natural regeneration to establish in the forest without the need of plantation, for example. Another aspect of management, along roads again, thinning pine seedlings along forest dirt roads. It's a major thing that we have to do because the pine regeneration of pine seedlings are very, very large in large scale, and we have to act very firmly and consistently to make sure that we don't have a very dense cover of pines because we want to ensure the next fire find us in different situation. And another last example is pruning, that we have to do a lot to support establishment of young broad-leaved trees. Here we can see Omer from our department in the Gilboa Mountains actually does this activity in young broad-leaved tree, and we can see it before and after. And this pruning management activity support, as I say, the establishment and the long life of the tree. And actually, it's a very important activities that we have to intervene and to come into the forest to make sure the rehabilitation of this area in the forest after a wildfire. So after those few examples, I will sum up. So natural regeneration is a nice and very useful basic concept for us. But I want to emphasize it demands us for wise management. And if we do it, we can achieve continuous cover, which is very important for us. We can see two pictures. The upper one is from the Meron mountain in the Upper Galilee. And on the right side from the Jerusalem mountain, from the Kedoshim forest. Different types, different age. We get multi-age forests. We have the patchiness, the complexity of the forest. We support biodiversity by this heterogeneity and complexity and the multi-age forest that we have. And in addition, we increase the resilience of the forest against droughts, against other things, and of course, for the next fire to come that we want to prevent. Thank you very much.
Thank you very much, Gilad, for a fascinating talk. Our next speaker is Tamar Aviv, the head of Biodiversity Unit at the Israeli Ministry for Environmental Protection, and her talk will be on using the nature-based solution approach to develop urban resilience. Please,
Thank
Tamar.
you, Noga. Hello, everyone. After the interesting presentations from my colleagues, Doron and Gilad, who talked about building resilience in open spaces, then I'm here today to talk about how we use nature-based approach to develop urban resilience in Israel, in the more intensified urban places. So I will start with a few facts. It's just the wrong presentation, sorry. Okay. Thank you. So I will start with a few facts about, and now it's not working.
The clicker?
The clicker's not working? Huh? No, it's the red one. I'm sorry, the clicker's not working. Okay, so I'll start with a few facts about Israel that are relevant for the presentation. The population in Israel is approaching 9.5 million, and the annual population growth rate is very high at 2% a year. 93% of the population lives in urbanized areas. And because of the population growth, planning for housing is intense, with about 1.5 million new units expected in the next 2 decades. Also, there are 257 local authorities in Israel on a small area. From a geographical and ecological perspective, Israel is set at the meeting point of 3 continents and 4 geographical regions. And there is a steep altitude gradient rising from over 220 meters in the north to under 417 meters below sea level at the Dead Sea area. There is also a steep rainfall gradient of 1,000 millimeters per year in the north, but only 50 millimeters per year in the south. And we are at a semi-arid climate, as Noga said, which includes a Mediterranean climate and a desert climate as well. We have identified locally 23 distinct ecosystems, and we are also an important bird migration path. So all of these facts imply that we are a biodiversity hotspot with many endemic and important species of plant and animals. Unfortunately, land is scarce in Israel, and there are many negative key drivers that put biodiversity at risk. You might know many of these negative key drivers because they are universal. You're probably familiar with them, but we have land degradation and overexploitation of our natural resources, invasive species of plants and animals, and infrastructure such as roads and even wind turbines that cause collision for animals. All of these are putting pressure on our biodiversity at a national level, and we do a lot at a national level to protect biodiversity, such as nature reserves and national parks. But they also affect biodiversity at a local level too. So we are here today to talk about climate change, and I wanted to exhibit how urban nature at a local level, using nature-based solutions, can help dealing with climate-related issues and help cities adapt. Here are some photos of climate-related hazards. The one on the top left, for instance, is a winter pond that has not received its rain. It's November in Israel and still no rain, and it's unfortunately set on fire just this week in a very urbanized area, the city of Netanya. But we also have floods, and we have other climate-related issues, storms, and drying up of our water and aquatic habitats. So nature-based solutions, as Noga said before, I will repeat it, are actions that protect, sustainably manage and restore natural or modified ecosystems that address societal changes effectively and adaptively, while simultaneously providing human well-being and biodiversity benefits. So we're talking here about benefits not only for biodiversity, obviously for humans as well, and that is what is important about this concept. So Israel for many years has been promoting the conservation of biodiversity at the local level, and even before our current discussions about how biodiversity at the local level can help climate change, we have always seen benefits from urban nature. And we have a methodology of developing urban nature, which starts with data, continues with policy, then conservation and rehabilitation of urban nature sites, and then management and obviously public awareness. And I will go into this in more detail. So the first stage is collecting the data, and we have for more than a decade been assisting and helping the local authorities prepare urban nature surveys. These surveys try to map out all of the urban nature sites and ecological values within the city or the town. And you can see here some examples of the maps at the bottom of some of the cities of Arad and Nes Ziona and Ra'anana. All of these are published online. And the top two shows the progress in the southern and Tel Aviv districts of how many local authorities have already conducted one of these surveys. So the green is where the cities have completed the survey, and the yellows are the ongoing. We already have 50 out of our 257 local authorities with a survey, and we hope that by 2030 we will have all of the local authorities will have conducted a survey. The second stage is policy papers and guidelines, and this helps the local authorities and gives them tools on how to implement and preserve urban nature within the municipality. One of the interesting things that has happened in this development is that we have a new job. It's called the municipal ecologist, who helps with implementation. The third stage is implementing ecological considerations in planning within the municipality and development of urban nature parks, usually areas that have been degraded and run down. And obviously the fourth stage is education, public awareness and engagement. This is not linear, this is something that is ongoing all the time. So I will be giving 3 examples to demonstrate the nature-based solutions approach in the urban environment. The first is the Gazelle Park in Jerusalem. The gazelles populated this area, which is in the center of the city, and that became more and more enclosed due to surrounding development until they were literally locked in this area. And after 20 years of public opposition, the municipality decided to develop a park there rather than housing, and it opened to the public in 2015. Now, the project included rehabilitation of the degraded land and applying nature-based solutions for treating runoff water and groundwater, including developing a winter ponds, cascade of winter ponds that you can see here. The park today is one of the main free tourist attractions in Jerusalem. It's home not only to a big group of gazelles, but also to many species of plants and animals. The second project is the rehabilitation of Lev HaSharon winter pool in the most densely populated part of the country, the central part. Winter ponds are an important habitat, but unfortunately were not appreciated over the years. But the last few years, we have seen many winter ponds have been rehabilitated, and there's more understanding of the importance of this habitat. And the project is completely nature-based, providing connectivity between natural areas and enhancing pollination for the agricultural fields close by, treatment of runoff water, and much, much more. The third case is an example of the desert city of Arad. After Arad performed the urban nature survey a few years ago, they began to think about the ways of enhancing biodiversity and engaging the public. So once a year, the city hosts an event called BioBlitz, and the public connects with scientists and ecologists that follow up with follow-up surveys. They take part in these surveys and connect to their surroundings. The data accumulated helps the municipality protect the important fauna and flora and to improve the ecosystem services, such as dust regulation and plant feed for livestock in the desert. So all of these projects are based on nature-based solutions, and they provide a variety of ecosystem services that you can see here. Climate regulation and carbon sequestration, of course, but also, and importantly, in central areas, flood and landslide regulation. They also provide for pest and disease control and treating runoff and groundwater to prevent floods. In more intensified areas, the projects allow for reducing urban heat and air pollution, and in more open spaces like Arad, they provide a food source and livestock feed. And pollination obviously is another important part of ecosystem services. But it also provides for an area of cultural services and education as well. So if we're talking about co-benefits, then there are many here in these projects, and the approach of nature-based solutions in the urban environment. For biodiversity, it's the rehabilitation. It provides for rehabilitation of endangered habitats and rewilding as well of plants and other species of animals. It supports biodiversity at the nationwide level as well. We have found within these surveys many endangered species, and some of them are even new species that are new to science. It reduces pressure on nature reserves because people can choose to go to these parks rather than go to the nature reserves and travel far away. It enhances connectivity. And it allows for protection of threatened and endangered species, providing food and shelter for migratory species of birds, and obviously helps with battling climate change from a mitigation and adaptation point of view. For humans, it allows for a better quality of life and health, makes nature accessible for all those who can't travel as well. It allows for sustainable local planning and management within the municipalities, provides for tourist attractions, and is, more importantly, environmental and economic. These urban nature sites, if they're designed and managed in a good way, then they save a lot of money for the municipalities. It also helps develop a local identity by engaging the public in the activities, promotes education, public awareness, and activism as well. And also, from the human side, it helps battle climate change. So our vision for urban nature and nature-based solutions is that urban nature will be applicable in all local authorities. That is why we would like that all local authorities would have the survey to start. It allows for developing green and blue infrastructure, taking into account the different habitats. Developing accessible urban nature sites in every city is key to the success of this kind of approach. And obviously implementation of ecological considerations within planning and management. All of these together will help build a more resilient urban environment. Thank you.
Thank you, Tamar, for this excellent talk and for all the work you do. I will give the next and the last talk of this session. I'm Professor Noga Kornfeld-Chor. I'm the Chief Scientist of the Israeli Ministry for Environmental Protection. And my talk will focus on climate change, nature-based solutions and health, or how we can use nature-based solutions to reduce health risks. Can I have the clicker? Okay, thank you. Health risks are determined by exposure to a hazard and the vulnerability of the exposed individuals or society. Climate change influences all three: the hazard itself, the chances of being exposed to it, and our vulnerability. The results of climate change will be that some existing health hazards or threats will increase and intensify, and new health threats will emerge, including vector-borne diseases, water and food-borne diseases, direct injuries or deaths, heat-related illnesses, and mental health issues. And the results are already here. The WHO Health and Climate Change Survey report from 2019 found studies reporting an effect of climate change on vector-borne diseases and water and food-borne diseases in 23 countries, effects on direct injuries and deaths in 21 countries, effects on heat-related illnesses in 21 countries, and effects on mental health issues in 6 countries. And these are clearly a huge underestimate of the real situation. So how can we use nature-based solutions to reduce these health risks? We heard in this sessions 3 talks on 3 different habitats. And in the following part of my talk, I will first give you general examples of how restoring and rehabilitating each of these habitats can contribute to health, and then give you 3 specific examples from studies conducted in Israel. So we first heard from Doron on wetland restoration. Wetlands provide flood mitigation and can therefore reduce direct injuries. Sorry. They also filter water, provide a habitat for healthy biodiversity, and can provide different benefits depending on the specific locations. Not all wetlands are alike. and health benefits depend on the specific goals and risks to both humans and biodiversity. Like every other action of nature, wetland restoration must be done thoughtfully, for example, while making sure it will not become a breeding ground for pests like mosquitoes. But functioning, healthy wetlands can enhance disease regulation among its benefits. And I will give you an example from Israel later on in my talk. The second talk was on forest restoration. A forest with full range of biodiversity, including predators and local biodiversity, can mitigate the spread of some infectious diseases, particularly those who spread with rodents and mosquito vectors, such as West Nile virus, Lyme disease, and some of the hemorrhagic fevers. Fragmented habitats, on the other hand, increase the interaction of the vectors with humans, may affect reproduction and behavior of the vectors, alter complex predator-prey dynamics, and stimulate evolutionary processes and diversification of diseases. The protection and production of functional, well-connected habitats have clear benefits for human health, as well as mitigating biodiversity loss and climate change. The third talk focused on urban nature. Studies show that urban nature, blue or green, lowers stress, promotes faster recovery from psychological and physical events, increases air quality, stimulates physical activity with its related beneficial effects on health, and decrease ambient temperature. All these promote health, and in all of these cases, it is important that the rehabilitation, restoration, and generation of the habitat will be based on scientific ecological understanding of these fragile and complex systems. And I will now give 3 examples from studies conducted in Israel. Leishmaniasis is a parasitic infection caused by different species of Leishmania protozoa. It is transmitted through a bite of infected female sandfly. In Israel, we have cutaneous leishmaniasis, which is caused by Leishmania major, whose reservoir are desert rodents, and Leishmania topicana, whose reservoir are rock hyraxes. On the graph, you can see the number of cases of cutaneous leishmaniasis in Israel in blue. Looking into the ecological setting in which the disease life cycle occurs, it becomes clear that in both types, anthropogenic disturbances enhance the occurrence of the disease, and that a deeper understanding of the ecosystem and using nature-based solutions can help to reduce the risk. So let's start with Leishmania topicana, whose reservoir are rock hyraxes, which you can see here in the pictures. This species was common in Israel along the Syrian-African Rift Valley. Hyraxes form large colonies in rock piles, and in recent years there was an outbreak of Leishmania in Israel. And a study conducted by Ben Moshe and Iwamura found that artificial rock mounds, a byproduct of the common building practices in Israel, encircled new neighborhoods in Jerusalem and created a great shelter for wild rock hyraxes next to rich foraging grounds in the city parks. And the result is an outbreak of Leishmania in new areas. The easy solution for this risk is avoiding creating these rock piles, which formed a new habitat for the hyraxes. This is a great example of how keeping nature intact at first place, or restoring the natural habitat just by eliminating these man-made shelters for the hyraxes, can prevent or reduce the Leishmania outbreak. A second example for a similar system is that of Leishmania major. The outbreak was in desert settlements in Israel, and resulted mainly for the influence on the vector, the sandfly. A study that was conducted in settlements in the Israeli deserts found that in these desert areas, the addition of water for gardening improves the condition for the vector breeding, the sandfly, and promotes larger host population, the sand rat, by improving the quality of their food. Together, this resulted in enhanced disease transmission risk to humans. So in this case, using local vegetation, which does not require irrigation, is expected to result in reduced risk of infection by Leishmania major. The third example I would like to give is from the Yarkon River at Tel Aviv. During the 50s, all its water was used and it was almost completely dry. With time, it became increasingly polluted. Sewage replaced the flow of fresh water, habitats were destroyed, and flora and fauna disappeared. This was exacerbated by continuous discharges of industrial effluents and municipal sewage into the river. It became a habitat for pests, invasive species, and mosquitoes, and was repeatedly treated with insecticides based on mosquito larvae occurrence. In the figure, you can see the number of pesticide cycles per year used in different parts of the river. On 1997, a bridge on the river collapsed during an international sports event, which led to the death of 4 athletes due to infections caused by the exposure to the polluted river water. And this was a turning point. The river was dredged to restore its original depth and natural flow. Riverbanks were raised and reinforced, and this improved the quality of the wetland and enabled fish reproduction. Extinct fish species, as well as new species, which prey on the mosquitoes' larvae, were reintroduced, and populations of many other species recovered. And all this eventually led to rehabilitation. The river is still considered unsafe for swimming, and there is much more that should be done. But since 2009, there's no need to use insecticides in the river, and their use was stopped, further enabling the restoration of the local arthropod communities. So instead of using pesticides and insecticides, restoring this river solved the mosquito problem around it. All these 3 examples are nature-based solutions for health risks, and many more examples are out there. We just have to look for them and use them. The solutions must be based on deep understanding and scientific knowledge of these complex and fragile ecological systems that surround us and which we rely on. By studying nature and understanding ecological interactions, we can use nature-based solutions for the benefit of our health and the health of the environment. Thank you very much, and I will now open the discussion for questions. So if any of the audience have questions, please raise your hands, and we will be happy to answer them. Okay, so if there are no further questions, I would like to thank the speakers again for their wonderful talks, and thank you for listening.